So in this video, we're going to do the first example of finding a probability. First, I'm actually going to be skipping the rest of this page as we're going to fill in these useful relationships when they're most applicable to the problem that we're doing. So we're going to dive in and do example A in this video. This time, instead of working with Kentucky basketball scores, we're working with women's heights. It can be approximated by a normal distribution, so it has that bell-shaped curve with a mean of 65, giving us our mu, and a standard deviation of 2.75 inches. And again, remember this is that shorthand notation that's saying the exact same thing. Women's heights is distributed normally with a mean of 65 inches, standard deviation of 2.75 inches. Using this idea, we're going to find the probability that a randomly selected woman is 63 inches or shorter. We're now going to follow those steps discussed in the previous video. So we're going to graph our bell-shaped curve and plot the mean. So we already have the start of our curve here for us. Our mean is 65. And since our standard deviation is 2.75, that's how big each of my steps are going to be here. So I'm going to subtract 2.75 each time I go to the left. So the first time, that's going to get me 62.25 inches. Subtracting 2.75 again gets me 59.5 inches. And subtracting it one more time gets me 56.75 inches. Now moving to the right, we're adding the 2.75 each time. So we get 67.75, 70.5, and then finally 73.25. So I'm always just going to start by putting my scale along the bottom. Our next step is to plot our value or values of interest relative to the mean. So in our particular problem, the value 63 shows up. So where is 63 on my picture? Well, it's between this 62.25 and 65. So it's roughly about there. And then we're going to figure out which way I should shade. So where are women that are shorter than 63 inches? Well, that's going to be to the left or below that height. So basically those first three steps are to draw your according picture. Now, a couple things I already want to talk about with this picture to see that our answers are going to make sense as we go. Remember that we talked about how the z's correspond to the values here. Right, so 65 would give me a z of 0. The 62.25 would give me a z of -1. I can see that my 63 is going to be somewhere between -1 and 0 when I calculate my z. So let's actually do that and see how that should make sense. So our z, our observation, is that 63. The mean is our 65. And our standard deviation is 2.75. Doing the math here, we get a z-score of -0.73. which is right between that -1 and 0, as I said it should be. Now let's talk about what I can also tell from this picture when it comes to the probability I'm going to get for my answer. If I had everything to the left of 65 shaded, I would have exactly 50%. Because as when we talked about the normal curve, it's 50% below the mean and 50% above the mean. Thus, I can tell from my picture alone that my answer better be less than 50%. Now, how do we actually go about in calculating this probability? Well, I can't use my normal curve rule here because I didn't follow one of our perfect little increments away from the mean. So now I'm going to have to use that table that I showed in the last video. So how are we going to use that table? Well, if you look at the steps here, it says one of the last things we're going to do here is to go to that table appropriately. Let's discuss what I mean by appropriately. Well, looking at our table, now we have this little picture at the top that is here to help us. So our table is shaded left, right? Every time I come to this table, it's going to be shaded left. That's never going to change. Well, which way is my picture shaded? It's shaded left, so I actually have a match. So what that's going to mean for me is I'm going to be able to take this number straight to the table. And now how I'm going to read this table. Up through this first decimal point tells me the row I'm going to go to in the table. And that second decimal point is going to tell me the column I'm going to go to in that table. So I want to go to the row of negative 0.7 and the column of 3. So my negative 0.7 row is right here. And the 0.03 column is actually the fourth column here. So finding where those line up would give me this value of 0.2327 in the table. So from that table I found 0.2327. And again then, since my table is shaded left and my picture is shaded left, this is actually going to be the answer to my probability, because it was a match. Table was shaded left, my picture was shaded left. So then now putting this back into the context of the problem, so then I can say the probability that a randomly selected woman is 63 inches or shorter is 0.2327, or if you prefer, we can multiply this by 100% and change it to a percentage and say 23.27%. When you're doing homework tests, just be careful to see if it wants the decimal form or the percentage, so you know which one to enter. But so a probability of 0.2327 or 23.27%, and that is less than our 50% like we thought it should be. So then quickly to recap, when my picture is shaded left, I'm going to calculate my z-score, I'm going to go to my table appropriately, and that is just going to be the answer to my problem as long as my picture is shaded left. So what happens when we're not shaded left? That's where the next video comes in.